Hi friends, in this video we are discussing statement and proofs of the Euler's theorem on homogeneous functions. Now the statement of Euler's theorem is if U is a homogeneous function of degree n in x and y variables, then first condition is we have x into dou u by dou x plus y into dou u by dou y is equal to nu. And the second one statement we have x square into dou square u by dou x square plus 2xy times of dou square u by dou x dou y plus y square times of dou square u by dou y square is equal to n into n minus 1 into u. Okay friends, I am repeating again. If u is a homogeneous function of degree n in x and y variables, then we have first one is x into dou u by dou x plus y into dou u by dou y is equal to nu, and second one we have x square into dou square u by dou x square plus 2xy into dou square u by dou x dou y plus y square into dou square u by dou y square is equal to n into n minus 1 into u. Okay, where u is a homogeneous function and ux comma uy are called first order partial derivatives with respect to x and with respect to y. Okay, and uxx, uxy, uyy are called second order partial derivatives. Now we are discussing first proof. From the statement you can say u is a homogeneous function of degree n. So we have different forms when u is a homogeneous function. So I am considering u of x comma y is equal to u of x comma y is equal to x to the power of n into f of y by x. You consider this as equation number 1. Now we have to prove x into dou u by dou x plus y into dou u by dou y is equal to nu. So we need to find out the partial derivative, first order partial derivative of u with respect to x and with respect to y. So differentiate equation 1 partially with respect to x and also y. First I am differentiating equation 1 partially with respect to x. You can say dou u by dou x is symbolically you can write ux only. Now here you observe, if I differentiated partially with respect to x on both side of equation 1, then we will have ux is equal to, here you observe right side part, what you have, x power n into f of y by x. This f of x comma y is also a function of x. So we have to apply uv rule. We know that uv dash is equal to u into v dash plus v into u dash. Also you can say first term into second term derivative plus second term into first term derivative. Now we are doing first term into second term derivative. F derivative is f dash of y by x and inner derivative with respect to x. While differentiating partially with respect to x, we have to treat other variables as a constant. So here inside of the bracket we have y. So what about the x? X is in the denominator. So we have 1 by x. What is the 1 by x derivative? Minus 1 by x square. With respect to x is minus 1 by x square. So you have to write into minus 1 by x square plus second term into, what is the second term here you have? F of y by x into x power n derivative n into x to the power of n minus 1. Now friends, you see here you have x power n, here you have in the denominator x square. So if you are simplified, then you will have x to the power of n minus 2, here minus is there, into y f dash of y by x plus n into x to the power of n minus 1 into f of y by x. Okay, this is the value of dou u by dou x. Actually what you have to prove, x into dou u by dou x plus y into dou u by dou y is equal to nu. So multiply x on both sides, then you will have x into dou u by dou x is equal to minus x to the power of n minus 1 into y into f dash of y by x plus n into x to the power of n into f of y by x. You consider this as equation number 2. Okay, now we have to differentiate equation 1 partially with respect to y. Then right side, left side is uy you have, right side you observe friends, in the equation 1, first term is x power n, second term is the function of y. So first term you can treat as a constant because it is independent of y. So x to the power of n into, now f derivative, function derivative is what? F dash of y by x. Now inner derivative with respect to what? Y. Y is in the numerator. So y derivative is 1 and 1 by x is a constant. Okay. Now here you have a x, uy is equal to x to the power of n in the numerator. In the denominator you have x. So you can also write this as x to the power of n minus 1 into f dash of y by x. Now you observe friends, in the first equation we have to prove xux plus yuy. So multiply with y on both sides. Then you will have y into dou u by dou y is equal to y into x to the power of n minus 1 into f dash of y by x. You consider this as equation number 3. Now from 2 and 3, what you can say? Actually we have to add these two equations. Now if I added 2 and 3, then x into dou u by dou x plus y into dou u by dou y is equal to, this is minus x to the power of n minus 1 into y into f dash of y by x plus n into x to the power of n into f of y by x plus y into x to the power of n minus 1 into f dash of y by x. Here you observe, are you getting anything cancelled? Yes, you have a negative x power n minus 1 into y into f dash of y by x and positive y into x power n minus 1 into f dash of x. So the remaining terms what you have, you see, n into x power n into f of y by x. What is x power n into f of y by x we have? From the equation 1, you can say this is u of x comma y. So we can write x into dou u by dou x plus y into dou u by dou y is equal to nu. Hence proved the first statement. So let us go for the second proof. Okay friends, what we have to prove? Second one, x square into dou square u by dou x square plus 2xy into dou square u by dou x dou y plus y square into dou square u by dou y square is equal to n into n minus 1 into u. Okay, to prove this one, we are using the first statement. That is, if u is a homogeneous function of order n in x and y, by Euler's theorem, we have x into dou u by dou x plus y into dou u by dou y is equal to nu. Consider this as equation number 1. Actually, what you have to prove? X square into dou square u by dou x square. You see friends, you have ux and also uy. I need to find out uxx. Nothing but we have to differentiate ux again with respect to x. So you will get a uxx. Later you have uxy. This ux you have to differentiate with respect to y. Then you will have uxy. Of course, you can do uy with respect to x. Both will be same only. Okay. Next, you have uyy. If I differentiated uy again with respect to y, then I will have uyy. So, first, we are differentiating equation 1 partially with respect to x. Then we will have, here you see, product of the two terms we have. First term is x. Ux is also a function of x. Since u is a function of x, then ux, uy, uxy, uyy, all are functions of x only. Remember that. So, first term into second term derivative. That is, first term into second term derivative you have uxx plus second term into first term derivative. X derivative is 1. As here you have y into uy. Y is a constant or y is independent of x. So, you can write y is as it is. Now, uy derivative with respect to x is uy into x. Or you can also write uxy. It's not an issue. Now, this is equivalent to n into u derivative with respect to x is what? X. Okay. Now, you consider this as equation number 2. Again, you differentiate equation 1 partially with respect to y. Then we have, here you see, in the equation 1, you have x into ux. But we are differentiating partially with respect to y. So, treat x is an independent. That is, x as a constant. X is x. Ux derivative with respect to y is uxy. Plus, here you have product of two terms. Uy is a function of y is also a function of y. So, you need to apply uv rule. Uv dash is equal to uv dash plus vu dash, or first term into second term derivative. First term is y, second term derivative is uyy, plus second term into first term derivative, y derivative is what? 1. Okay, this is equivalent to right side part what you have n into u derivative with respect to what? Y. So, uy. Okay, friends. Now, here you observe, we required x square into dou square u by dou x square and y square into dou square u by dou y square. But here you have x into dou square u by dou x square. So I am multiplying 2 equation 2 by x and also equation 3 by y, and I am adding these two equations. Then we will have, if I multiplied x for the equation 2, then I will have x into x square into dou square u by dou x square plus x into ux plus yx into uyx is equal to right side. Okay, first I will add the left side, later I will add the right side parts. Okay, now plus what I am doing for the this equation number 3 here, for the equation number 3 I am multiplying y. So this will be y into x uxy plus y into y square into uyy plus uy into y is equal to right side part for this 2 I am multiplying x. So x into nux plus y into nuy, y into nuy. Okay friends, here you observe x square uxx plus y square uyy. Later the terms what you have, xy into, first I am writing these two terms, x square into uxx plus y square into uyy plus the remaining terms you see, this is uyx term, this is also uyx term. So both are repeated. So you can write this is twice of, that is nothing but 2 times of xy into uxy. Uxy is equal to uyx friends. You remember. Okay, na? In the partial differential equation for the second order partial derivative, uyx is equal to uxy because it is a homogeneous function only. And we have xux and yuy. So I am writing the remaining terms, that is you see xux plus yuy. What you can write from the equation 1? Nu. So from equation 1 we are writing nu. And from these two you can take which is a common term. Here you have n, here you have n. So if I take on right side n is a common, then again I will have xux plus yuy. What is xux plus yuy value from equation 1? Nu. Okay, I am writing this nu. Okay friends, consider this as equation number 4. How you are getting this nu means from equation number 1. Now we have to simplify this. For this you keep these three terms on left side. This is equivalent to, then first I am writing these three terms, x square into uxx plus y square into uyy plus 2xy into uxy. This is equivalent to n square u. This is n if I multiply right side, n square u. This term I am taking the left side, then I will have nu. From these two what I can take common? N square. Only u I can take common. If I take an u common, then I will have n square minus n into u, or else this one you can also write as n into n minus 1 into u. So this is the proof of the second statement for the Euler theorem on homogeneous function. Thank you for watching this video.